So in this video, we're going to talk about how to find the inverse function. So if we're given a function f of x equal to y, I want to find x equal f inverse of y. I'm looking for the inverse function. So how do I do that? So let's do an example. So here's your example. F of x equals the cube root of x minus 3 plus 7. Okay? So step one, replace f of x with y. Okay? So what do I get? I get y equals the cube root of x minus 3 plus 7. Step two, swap x and y. Everywhere I see an x, I'm going to put a y, and everywhere I see a y, I'm going to put an x. So this becomes x equals the cube root of y minus 3 plus 7. All I did was I swapped the x and the y. The swapping of the x and y sets up our inverse. Now, step 3. Solve for y. So how do I solve for y? Well, the first thing I'm going to do is I'm going to subtract 7. Look, I'm trying to get y by itself, okay? So to get y by itself, I need to subtract 7. So I get x minus 7 equals the cube root of y minus 3. Now to get rid of the cube root, I cube both sides. So I have x minus 7 cubed equals y minus 3. And to get y by itself, I add 3 to both sides. So I have y equals x minus 7 cubed plus 3. And the last step, step 4, replace y with f inverse of x. So my answer is f inverse of x equals x minus 7 cubed plus 3. So this is the inverse function for what we started with. Right here. Okay? So let me copy this in. So that's my answer right there, f inverse. That's the inverse function. Now, one thing that is interesting about the inverse function, one thing that's interesting about it is that if I compose the two inverse functions, then I will get the same thing. F composed of f inverse is equal to f inverse composed of f, which is equal to x. Right? Very interesting here. So let's try it out. So this says f of something. So I take the f of, and then what is my something? My something is f inverse of x, right? So this is the cube root of f of something minus 3 plus 7. So I need to make this a little bit bigger so that everything in here will fit. So that's my something, right? So then when I simplify, this gets me the cube root of x minus 7 cubed. Now, plus 3 minus 3 cancels, so that's just 0, and then plus 7. Well, the cube root of the cube, that just undoes itself, so that's x minus 7 plus 7, and that just gets me x. Okay? If I went the other way, if I did f inverse of f of x, well, what is f inverse defined to be? F inverse is this function here, right? So that's parentheses something minus 7 cubed plus 3. Now, what is the something here? The something is f of x, f of x is defined to be this thing right here. So let's take that thing right there, and we're going to plug it into our equation. I need to move this over so that it will all fit. Okay. And when I do that, I get the cube root of x minus 3, and then plus 7 minus 7 goes away. Cube it, and then plus 3. If I cube the cube root, that goes away, so I get x minus 3 plus 3, and this minus 3 and plus 3 cancel, and I get x. All right, so very, very interesting here. Basically, this right here, the composition, you think about inverse functions, they're reflected across the line y equals x. Why do you think when you compose the two, it produces x here? Because it's reflected across this line here. So if you were to graph this, so let's say f of x was, what was f of x? It was the cube root of x minus 3 plus 7, right? So minus 3 tells me to go to the right 1, 2, 3, and then up 7, 1, 2, 3, 4, 5, 6, 7. And so what does, oh, I need to circle all that. Okay, so what does that look like? The cube root looks like that. Okay, and this point is 3 comma 7. Now the inverse function f inverse of x is equal to what? What did we find? We got x minus 7 cubed and then plus 3, right? Isn't that what we got? Yeah. Okay, so this means to go to the right 7, 1, 2, 3, 4, 5, 6, 7, and then up 3, 1, 2, 3, so right here. So my cube root, cube root goes up like this and then down like that. All right, and so this is 7 comma 3 here. So maybe I should make this line, maybe I should make the dots look a little bit better here. All right, so it's a reflection across the line y equal x. So obviously when I compose them, they will give me a point on this line here. Okay, that's why that f of f inverse of x is equal to x. When I compose the two functions, they give me a dot on the curve. Okay, so that's the idea there. Inverse functions. We literally swap the domain and the range. Now, it just so happens that f of x, the domain for f of x, well, what x's work for this curve? All x's work, right? So the domain's from negative infinity to infinity, and then the range, even though it may or may not look like it, this range, this is going down to negative infinity, it's going up to positive infinity. So the domain and the range are the same. So f inverse of x, when we're swapping two things that are the same, it's literally going to still just be the same thing. Okay, so still going to just be the same thing there. All right, so it really can't tell the difference because both domain and range are all real numbers anyway. Okay, let's do one more just to make sure we understand the process of how to find f inverse, and then we'll be finished. So f of x equals x minus 3 over 2x plus 1. Okay? So first thing I'm going to do, I'm going to replace this with y. So I'll get y equals x minus 3 over 2x plus 1. And now every x becomes a y and every y becomes an x. And the goal is to solve for y. But look, we've got two y's. Oh man, we got to get y isolated. So my suggestion, you do whatever you want, but I would get rid of the fraction. Okay, so to get rid of the fraction, I'm going to multiply both sides of the equation by 2y plus 1. And when I do that, this becomes 2y plus 1 times x equals, well, 2y plus 1 times y minus 3 over 2y plus 1. What happens with the 2y plus 1s? They cancel. So if I distribute this, I get 2yx plus x equals y minus 3. Now I want to get y's by themselves, so I need to get the y's to one side. So I'm going to subtract y. Okay, so that gives me 2yx minus y plus x equals negative 3. I'm going to minus x from both sides because I want the y's by themselves. I got two terms with y, and this one does not, that last one doesn't have a y, so I'll move it over. So I have 2yx minus y equals minus x minus 3. Now look, guys, I've got a y in this term and a y in that term. Most common thing people forget in this whole class is to GCF. I can pull a y out of both of those. If I factor a y out of both of those, I have a 2x minus 1. Okay? And if I divide both sides by 2x minus 1, I have now solved for y. So y is equal to minus x minus 3 over 2x minus 1. And so I'll replace y with f inverse of x. And I have my new function. Okay? So that's f inverse. I think f of x was what was f? It was x minus 3 over 2x plus 1. Now, this is a rational, so what can we not do? The domain of the f function, I can't divide by 0, right? So I set that equal to 0, solve for x. I get 2x equals negative 1, divide by 2. So x cannot equal to negative a half. So for the domain of the original function, it's all real numbers except for negative a half. Okay, so that's the domain. Now, if I wanted the range of this function, all I need to do is look at the domain of the inverse function, because the domain of the inverse function is equal to the range of the original function, right? Remember that key idea there? Those two things are equal. So how do I get the domain of the inverse function here? I set the denominator equal to 0. 2x minus 1 equal to 0. This is what you can't have, so I'm going to add 1. I get 2x equals 1, divide by 2. So as long as x doesn't equal a half, we're good to go. So what is the domain of the inverse? Negative infinity to 1/2. And then from 1/2 to infinity. So that is equal to the range of the original, right? Remember, okay, f, the original, has a domain and it has a range. The domain was from negative infinity to negative a half and negative a half to infinity. We didn't know what the range was yet. But what we do know is that f inverse has a domain and a range. And the domain for that was negative infinity to 1/2, positive 1/2, and then 1/2 to negative or positive infinity. Now, the relationship between the domain of the original and the range of the inverse, you're doing what? When you do the inverse, you swap x and y. Okay, so what does that mean? The domain, the x's become your y's. So this becomes negative infinity to negative 1/2, union negative 1/2 to infinity. And then the domain of the inverse becomes the range. So this becomes negative infinity to 1/2 union 1/2 to infinity. So that's how you get the domain and range of that rational function applying your inverse techniques. All right, guys, good luck.